Okay, hi everyone. So let's talk about the electric potential difference for a point charge. I've actually just written it right here for you. This is how we're going to represent our electric potential difference that a point charge produces. So maybe not surprisingly, a point charge is producing an electric field, right? We figured that out in a previous section of the book. So a point charge produces an electric field. It also produces an electric potential difference. And a form takes something like this, where we have our K value, our K constant, this is going to come along for the ride. We have our Q, so some charge Q is going to be producing this electric potential difference. And then this R is going to be the distance from that point charge to a location where you want to measure the electric potential. So if I've got some charge here plus Q, this is the same Q in this electric potential difference. And let's say I want to measure the electric potential difference at this point here. Well, all I need to do is figure out what this distance is here between the charge and the point where I'm measuring to figure out what my electric potential difference is at that point. So if I have a very large charge, my electric potential is going to be much bigger. And if I'm really far away, it is going to be much smaller. Now notice I don't have a difference here. I don't have a delta. I haven't written a delta. But what I've done is I've already set my reference point. And what I'm doing is I'm setting my reference point here to be V is going to be equal to 0 when you are infinitely far away. So when you're infinitely far away from this plus Q charge here, I've said that my potential is going to be 0. So I'm essentially saying like KQ over R minus 0 is just going to be my potential difference here. So I'm setting my reference point, like we talked about in the previous video, to be V is equal to 0 when you're infinitely far away. And we've made a similar decision when we talked about gravitational potential energy, when we said that something that's infinitely far away will have 0 gravitational potential. So we've seen this type of setting our reference type before. So now we've seen that a point charge can produce an electric field, and also it will produce an electric potential. And now we have an understanding of, if we go back to our electric potential energy, this is equal to Q test times delta V. So if we have a test charge sitting near some other charged particle, if we've got my test charge near this plus Q charge here, it's going to feel some electric force from the electric field that's produced by the plus Q charge here, and it's going to experience, depending on where it is, an electric potential. And now we can sort of think about how this electric potential energy will change depending on my potential that I see here. So that is basically electric potential difference for a point charge.